Lesson 10.2 is sketching derivatives. Directions say the graph of function f is shown on the graph below. On the axes beneath, or over here on the side, sketch a possible graph of f prime, the derivative of the function f. You must take into account the concavity of f, so how it's bending. So the inflection points of f are shown. These are green dots on Delta Math. So the best thing to do to be getting started here is let's make an f prime. It's called a sine chart. I'm not even going to make my line go all the way. We know we go from -9 to 9. So I'm going to make my function stop from negative 9 to positive 9. Okay, so since I'm talking about slopes, the time that my critical points are going to come from when the slope is either undefined or 0. Those are the special points. And that's going to happen when I see relative mins or maxes. So -2 needs to be a critical point. And then I also see here at 3, the slope would flatten out. And that's the only 2 points that I see. So then your job is to look at this and say, okay, right now my slope, if I were to draw these little tangent lines, my slope is increasing. So I'm going to put a plus sign there. I get to this maximum here where slope is 0, and then I decrease. So I'm going to put a negative here for this interval. And then I go to 3 and I flatten out, my slope's 0, and then I'm still decreasing. Okay, then I'm going to make another sine chart that's f double prime from -9 to 9. This has to do with the concavity. And the points, the critical points to me in f double prime are going to be the points of inflection. So where they have the points already made for me, that's -6. And I want to put it where it would fall in this number line. I know it's not always drawn to scale here, but I'm going to put -6 between -9 and -2. There's another one here at 0, which would fall between -2 and 3. And then here at 3 would match up with the 3 above it. Okay, so then I'm just asking myself whether it's concave or up or down on those intervals. From x's -9 to -6, right here. Kind of hard to tell, but if I were to extend this, see how that's concave up? So I'm going to put plus. The interval -6 to x is 0, that's concave curving down. So I put a negative. 0 to 3, I'm concave up, positive. And 3 to 9, I'm concave down, negative. Now what I want to do is split this into every possible interval. So I'm going to make ordered, they look like ordered pairs, but I'm going to make intervals with my x values. I'm going to go -9 to really the number that would come next would be -6. Something specific is happening from x is -9 to -6. Then I have to be from -6 to the next number I'd get to is -2. Then -2 to 0. Then 0 to 3 is the next number, and then 3 to 9. So sometimes you share the same intervals in your f prime and f double prime, and sometimes you have to jump back and forth. You just have to keep it in order. And we're going to make a little table here. So that's the interval. Oh, can't spell interval. This is the sign on that interval, and then this is the direction. Sine means, is it going to be above the x-axis or below the x-axis? And so from -9 to -6, I can think this, or look here, but I'm going to be here. My sine's going to come from f prime. So right here, I'm positive. But for -9 to -6, I'm going to be increasing. So this comes from f double prime. Okay, from -6 to -2, so that would be from here to here, I'm still going to be positive, but now from -6 to -2, I'm going to be decreasing. -2 to 0 would be here to here. I'm going to be negative. -2 to 0, I'm still going to be decreasing. 0 to 3, I'm going to be still negative. 0 to 3, I'm going to be increasing. And 3 to 9, I'm going to be negative. And I'm going to be decreasing. So then this helps you break it up into the intervals. So when x is -9 to -6, I'm going to be positive values. So I'm going to be above the x-axis, and I'm going to be increasing. until I get to -6. So it doesn't matter how you draw it, but you should be increasing until you get to -6. -6 to -2, I'm still going to be above the x-axis, but now I'm going to decrease until I get to -2. And then I'm going to cross over into the negative. So -2 should actually be a 0, which I know because here I said that my slope was going to be 0. So it might be easier to go ahead and put points here at -2 and 3, so we know we got to cross through at those points. -2 to 0, I'm now going to be in the negative y values, decreasing until I get to x is 0. 0 to 3, I'm still going to be in the negatives, but I'm going to be increasing. And then from 3 to 9, I'm still in the negatives. That means I bounce off of this point, and then I need to decrease as well until I get to 9. So something like that. Delta Math, I think, will be pretty forgiving on how you draw it, because again, we don't know specific x, y values from this. We just know slopes. That's all it tells me. Okay, let's try another one and see if it helps clarify a little bit. So here's my graph of f. I need to graph just the slopes. And so let's make an f prime sign chart. And we're going to go from -9 to 9. And I want to pick out the critical points where the slope is 0. That would be here at -7. That would be at -4. That would be at 0. And that would be at 5. Okay, so then you're looking at what are your slopes doing? First, I am decreasing, so my slopes are going to be negative. I get to 0, then my slopes increase till -4, get to 0, then they decrease. 0 to 5, I increase. And actually 5 to 9, I'm still increasing. All right, f double prime from -9 to 9. I want those points they made for me. That's at -5, which would go in between -4 and -7. At -2. At 2. And at 5. Okay, and then I'm looking at concavity. So this is increasing / decreasing slope that I looked at, and this is concavity. Okay, -9 to -5, I'm concave up. -5 to -2, I'm concave down. -2 to 2, I'm concave up. 2 to 5, I'm concave down, and 5 to 9, I'm concave up. So now we're going to make our table. We've got lots of intervals here. We always start with -9 on these. Next number I'd get to would be the -7. And then -7, the next number would be the -5. -5 to -4. -4 to -2. -2 to 0. 0 to 2. 2 to 5. 5 to 9. Ooh. Then we'll have our sign that tells us whether we're above or below the x-axis, and then we'll have our direction, whether we're, oh my gosh, direction, whether we're increasing or decreasing. So -9 to -7, f prime tells me it's going to be negative slopes. I'm going to be increasing. And then -7 to -5 would be in here. I'm going to be positives, increasing. -5 to -4, still going to be positives. I'm going to be decreasing, because that would be here. -4 to -2, I'm going to be in the negatives now. Decreasing. -2 to 0, I'm going to be in the negatives still. I'm going to be increasing. 0 to 2, I'm going to be now in the positives. I'm going to be increasing. 2 to 5, positive still, but decreasing. and 5 to 9 in the positives and increasing. So you kind of see this pattern here of every almost 2 it switched. So let's split that up here. It would be easier to go ahead and plot these on our graph. So we're going to have a slope of 0 at -7, -4, 0, 5, and 9. -9 to -7, I should be below the x-axis but increasing. -7 to -5, I'm now above and I'm increasing. So at -5 should be a relative max here, because then -5 to -4, I'm going to decrease again. My slope's 0 at -4, so I go below the x-axis, decreasing, until I get to -2. -2 to 0, I'm in the negatives, but I increase back up. 0 to 2, I'm in the positives, increasing. 2 to 5, I'm decreasing, but still in the positives. 5 to 9, I bounce off of here, and I'm in the positives. I didn't mean to point the point there, sorry. And I'm increasing. Yeah, that should not be there, that was just my end. Not a 0. Okay, so something like that. So what's happening is I've got all my slopes where they were decreasing, they're in the negatives. Where they're 0, they cross through the x-axis. Where my slopes are increasing, I'm positives. Slope is 0, I'm decreasing, slope is 0. I'm increasing, slope is 0. And then I'm increasing some more. So hopefully that all makes sense. Just take some practice.